Assalamu alaikum guys. So in today's lecture we are going to do waves. So what is wave? Wave is basically any disturbance in a medium that can transfer energy without the physical transfer of the medium itself. Okay? It's the classic definition of wave. What is wave? Wave is any disturbance in a medium, okay, that can transfer energy without the physical transfer of the medium itself. So basically from this definition we get that wave is basically a path of energy transfer, right? It is a path of energy transfer. But in this path, the medium is not transferred, okay? Means only the energy is transferred. And how is it done? So it is made up of periodic motion. What is periodic motion? Periodic motion is the motion repeated at regular interval. Okay, basically, it means oscillation or vibration. Okay, so this is how a wave is created by an oscillation. So the wave is a disturbance that transfers energy from one place to another. That's the basic definition. Like for example, if here is a person, okay, if we draw the person, and he gives a stroke to the rope, and in this rope, this disturbance moves on, moves on, moves on, moves on. Can you see this? This disturbance have moved, and this disturbance have moved till the end. So basically, the rope didn't move. Okay, like the rope didn't went there. Only energy went there. Only energy is used. Okay, so now we are done with the definition of wave. So basically, we in this there are two types of wave, mechanical and non-mechanical. But we will do only mechanical. Okay. So for mechanical, there are two types of mechanical wave. Okay, one is longitudinal wave, and the other is transverse wave. So what is a longitudinal wave? Longitudinal wave is basically the wave. So in this, the wave is moving in the same direction as the vibration of the source. Okay, like you see this. So in this, the wave is just moving in the same direction, okay, as direction of the source, okay, is the vibration of the source. Like for example, draw, let me draw some sound wave, okay, right? So here, if you see, these are some sound waves. So in this, what happens when we speak, the air particles in front of our mouth gets compressed, and then it relaxes, okay. So when it compresses, here the density increases. Okay, so here the density increases, so hence to make the density equal, it makes the energy transfer to the other particles, and like this it works. Okay, so this is the an example of longitudinal wave. Okay, and also slinky can also be example of longitudinal wave. Means that, like for example, this is a wave, right? This is a sound wave. Let's see. So in this, the wave is also going here, and the vibration is also going. Okay, so it's basically the basic definition which we can get from this is that it is a type of wave in which particles are moving parallel to the direction of the wave. Okay, wait, let me write this down. So what is a longitudinal? Let me write, like you should note this, okay, because it is the basic definition of longitudinal wave, you may say. Okay, so it is. I have written this definition, so you guys should especially more this definition of longitudinal wave. You may take a screenshot if you want. So what is the transverse wave? Transverse wave is basically the so the definition of a transverse wave is that when particles move to the perpendicular of the direction of movement of wave, then this kind of wave is known as transverse wave. Okay. So what does the definition tell? Like here, the it is written the direction of wave is perpendicular to the direction of vibrating source. Like this is the most simplest definition which I could have thought. Okay, so let me explain. Like for example, here is a rope. So what happens, like for example, is somebody who is training, right? So what happens that this rope is also moving up, right? When he pushes it up, and also moving in this direction. Like the wave is also moving this direction, and it is also going up. Okay, you get it? Basically, it means that when particles, like for example, that means the wave is moving in this direction, right? So the particles are also moving up and down, up and down. Like if you see here, the particles are up, and here the particles are down. So this is the perpendicular way. This is perpendicular, right? Here you can draw a 90-degree. Okay, so this is perpendicular. So hence the definition can be that when particles, wait, let me write the definition. Like this is the simplest, but let me write like another definition for it. Okay, so when particles, okay, so when particles move to the perpendicular of the direction of movement of the wave, direction of movement of the wave. Okay, so this is the, it means this the definition, and here this is also a good definition. Okay, so now what are some examples there? It can be slinky, string, and rope. Okay, so now let's move to some definitions. Okay, so now what is a wavelength? You know what's a wavelength? Basically, a wavelength is the distance between two consecutive identical points, such as two consecutive crests. Okay, so what is a crest, by the way, where the word crest is used, right? So basically, let me first tell you the meaning of crest. Crest is actually, sorry. Okay, so crest is basically the high energy portion in a transverse wave. Okay, so it is the high energy portion in a transverse wave. Okay, and what is a trough? This down one is called a trough, which is the low energy portion in a transverse wave. Okay, so this is a trough definition. This is a crest definition. So basically, now let's come to the wavelength. So what is a wavelength? Wavelength is basically the distance between two consecutive identical points, such as two consecutive crests. So, like for example, let me just draw an example. So wait, so now the distance between these two identical crests can be known as wavelength. Okay. Now, what's the symbol of a wavelength? So, symbol of wavelength is basically lambda. Okay, and the SI unit is meter. And okay, so you got it. So now let's come to frequency. So frequency is basically the number of wavelengths that pass a point per time. Okay, frequency is basically the number of wavelengths that pass per. So here it is. Yes. So here it's the number of cycles of wave completed per second, or this is also a good definition. This is also a definition. Both you can write in the past paper. So both can you can write in the paper in the past paper, because I have just practiced too many, so it's just coming in my tongue, because past papers are very important. So you have to do it. So what is the unit of frequency? So its unit is cycles per second. Cycles per second is basically hertz. Okay, hertz. 1 hertz is equal to 1 cycle per second. You got it? So now, what's the formula of frequency. Hmm? So it's one, two. Okay. Now let's come to the time period. Now, what is a time period? Time period is basically the time required to complete one cycle of a wave. Okay. So to complete one cycle of a wave or one oscillation or one vibration, you may call it whatever. Okay. One cycle, one oscillation, oscillation, or one vibration. Okay. So this is the time period. So now, what is the symbol of time period? Yes, symbol. So the time period symbol is T. Okay, and its SI unit is seconds. Now let's come to the amplitude. So what is amplitude? Uh, Okay, so amplitude is basically the maximum distance from the main position and it's the maximum distance between main position and extreme position. Okay, is known as amplitude. Okay, is known as amplitude. Now, there's no spelling mistake. Main position to extreme position. Okay, so this is the definition of amplitude. So now, if you see, uh, what does this mean? Like from main position to the extreme. Basically, yes, okay. So basically, if we see like, um, uh, actually, my drawing is a little bit weird. So if you guys can see this crest to the middle distance, like for example, it's two, and from the middle to the top, let's suppose it's two. So now if you plus it's four, like for example, so this is the amplitude. Okay, this can be the like for an example. Okay, now let's move on to wave speed. So what is the wave speed? Yes, okay, wave speed. So wave speed is basically the distance covered by a wave in a unit time. Okay, wave speed, distance covered, distance covered by a wave in a unit time. This is wave speed. So now what's the symbol of wave speed is basically, let's just write SY there. It's basically V and the unit is meter per second. Okay. So now what's the formula of wave speed? Formula, I think this pen isn't good. Wait, because you guys may not be able to see it, which I just noticed. Okay. So this is M/S. Okay, so the symbol is V. Okay. So what's the formula? Formula is basically V means the symbol, it's which is the wave speed, means the velocity of wave times F times lambda. So what is F? F, wait, V is basically velocity of wave, F is frequency, and lambda is the wavelength. Okay, Hmm, length. We have discussed the lambda that uh, it is a symbol of wavelength. Okay, so now we have just covered like the basic in this video. We have just covered the basics. Okay, we will make another video on waves because it's a lot to cover in it. It's a little bit tricky to understand. So you have to put a little bit focus on it so that you guys may understand it. And that's it for today, guys. I've just made this small video so that you guys may understand a little bit, like if you are new or just understand the background of it. Okay, so this is all from today, guys. I love this.